So, so today we'll begin our last season with some query regarding the past few days and also try to look into the NFHS data. So I have given a sample of the data because the data is huge of NFHS. So I have given a state data of each file. I'll come to that, but before that, I would like to ask if anyone having any issue regarding the last season or any earlier season, so that we can get the same page and get start. Yeah, if anyone can, if anyone having any issue, please raise your point. Hello, is my audio clear to all? Yeah. So if anyone having any issue, please let me know. Any query regarding the last season, regarding the testing hypothesis, or any easy plot or data manipulation, part filtering, any issue you faced, or your codes are running smooth. Okay. Uh, Maybe we can get some query regarding our season. Okay, let me start then. Uh, so we have the last day. Uh, what we have learned about, we have started with some data cleaning with the outlier data, where we have seen if there is a how many outlier are there, or the outlier which are more than some values, like we were saying it was for age, we are saying more than 66 or 50 something. We are giving some range. We can also see through the box plot stat also. Then we also had uh, seen a big data, large big data with various outliers as well as some data conspiracy, like there is some text in between the numeric variable or some numeric in the text. So how to detect those, and how to detect the NAs, how many NAs are there. So I have added those comments in the script if you see the last script which I have shared today morning. Okay, so that was about regarding the large data with what we have seen. Then we have started some statistical analysis like t-test or mean, checking in if there any difference in the mean for two groups. Then we have seen for the chi-square. Then analysis of variance also we have checked. Then I think correlation we have computed. What is what is the value is coming between, what is the linear relationship between the two variables. Then we go to the linear association or regression, you can say. Okay, so we have seen the normal linear regression. Then we went for uh, the, the logistic one. Yeah, if I can remember correctly. So then we went for some exporting the result. Uh, those in the TXT format you can export, as well as in the Excel also you can export. Okay, so that was up to that was for the last day. But I was saying yesterday also, there was some like plot you can also do. Okay, so there was a query like last year, if we can export the result into some latex format. Okay, so I'll show that one first. Then I can see some. I can do some graph. Then we can go to the NFH state. Okay, is it fine? Hope I'm not able to everyone. Okay. Okay. So let me share my screen. Okay. So this was the last script which I have shared with you. Uh, Maybe you have checked those codes. So this was the last part which I have talked about regarding the exporting. Okay. So now suppose we also want to see my screen is visible now.
Yes, sir, we can see your screen.
Yeah. Okay. Regarding what yesterday one of the participants has asked how to export the result into latex format. Okay, so for that you have to install the package called TextRage. Also, start writing this. Uh, this is the your package. Okay, so first you have to install the package. As we all know how to install, we have to write install.packages, and among the code you have to mention the package name. Okay. So let's start installing. Maybe it will take some time, I think. Yeah, it is now installed. So after installing, you have to write the all the library, same library which you have installed, okay, and run that one. So it will automatically run. Then after that, what you have to do, you have to write that how to export that result. Suppose we want to export the log underscore model, which was the logistic regression model. Okay. So first we have to mention the function which is it's the same function. Then we have to mention the model which we have stored that result log underscore model. So we have to choose that one. Then we have to mention book tabs also true, and then use dot package also false, and then we have to give the custom name. What was the custom model name? Suppose we want to give the custom model name which was logistic. Okay, so we just want to mention that because while writing the latex, those who knows the latex can understand. Uh, we have to mention the model name, and also we have to give the caption what we want to export, like I'm giving the caption like logistic regression result. Okay, and we also have to give the label. Suppose I'm giving the label as tab logistic, and bracket is with the commas. completed, I think. Just to keep the commas because it is continuing the function. Okay, so this is the comment. First, we have to mention the model name, then which tab, book tab, and then the package, and then the model name, what is the model name, and the caption. It, so first, okay, maybe log model it is not there in our system. Maybe I have cleared the environment totally. So that's why it was showing the log model is not found. So if you just can drag all the code and run, it will automatically run all of our chunk of the codes. Okay, and it will come automatically all those data which can be used for our exporting the result. Okay, after getting those, then we have if you run this one, you can give the latex syntax here. Okay, from here you can copy into your file latex file, and it can be that the table would come automatically. Okay. You just have to copy this one. You will get the you are getting the code, so you can copy that this code to your latex file, and it will automatically come as your table. Okay, this way you can get as your latex font. I hope those who are asked me got the answer. I don't remember who was asking last day. Okay, is it fine? Okay. Uh, okay. Okay, you were asking. I think it will work now. I can give the code also, the modified code to you in the same folder. I will upload. You can get it from me there, as well as I'm giving in your chat box, so can be used. Okay. Yeah. So that was the one thing we was showing. The second one, I think, regarding the number of NAs, if you want to see the NA rows, I think I have already given in the code only. Uh, yes, this one where NA is there in the age variable, you can show those codes. Those number of rows, how many rows are there, we can see. Okay, now the data is clean, so it is showing 0 rows. Otherwise, if the data is not clean, it will show there is number of rows is there. You can get it. I have given the comment, so you can look into those comments. Based on that, you can run and get those answers. Okay. Uh, One question was there: if we can add a column in the data set uh, to a new column. Okay, so I was showing like through the muted command. Okay, you can add a column, but that wouldn't be saved. Okay, that's the issue. So how you can do that one? So for that, you have to um, make you can use the muted one, but it won't be as a temp. It will be like a temporary result. Okay, so to change in your the data frame, you need to mention that want to make those change in your TF. Okay, so for that, what you have to do, you have to mention like this. Just muted the same command you have to use into DF. If you do this, then it will be automatically saved in your DF. I can show that now the modified DF to see. You can see the score percentage now is there here in the your data frame. But earlier it was not there. Earlier, if you run the muted command, okay, it will only show in the console only, but it won't be saved. But if you want to, if you are sure you want to add a column or a new variable, so you can add those. Okay, so but you have to mention in your TF you want to add those in your TF. Okay, this way you can add in the new variable. So this was one of the queries, I think. I don't think there is no more queries yesterday. Okay. So that was yes, that was from some status queries now. If we want to do some suppose graph, we want to make some graph. Suppose someone was asking the other day, like if you want to make some suppose some scatter plot and we want to add some regression line. Okay, so scatter plot we have already made, but we want to just modify that one with a smoothing. Okay, so first we want to write. We want to start writing the how the scatter plot we have made. If there is many more code, you can clean that those console also, and as well as environment also. This fits on. Suppose now, if you want to write, suppose P1, I'm giving a name P1. Okay, I want to make the scatter plot. So first we'll start with ggplot. Okay, ggplot. What was the result? Suppose I want to make them from the DF student data. Okay, so first we have to give the aesthetics. Along the aesthetics, suppose I want to score versus age. Suppose I want to make. Okay, so for x I have to mention what is x. So x I want to make the age, and y variable y-axis I want to give the score variable. Okay, so I have given the variable. Then you have to give some geom smoothing, okay, to give the regression line, and geom point you also have to give because this is scattered plot. Suppose I am to give want to give the geom point, and suppose we want to keep the we also have to keep the value of alpha, because when we do the smoothing we have to keep, when we do the regression line you have to keep the alpha value also, because the formula is y equal to alpha plus b beta x. Okay, so you have to mention what you want to take the alpha. If you don't want to take the alpha, you have to keep also the zero. Suppose I want to take the alpha as uh, 0.5, suppose. Okay, then we have to mention the how we want to keep the regression line. So suppose I want to keep the normal linear regression. Okay, so for that I have to keep geom smooth. Okay, then when smoothing we are want to give a line to the towards the scatter plots. Okay, so for that we are using geom smooth, and we want to give the method as lm, the normal linear regression, and standard error we want to give, so it is true. And suppose we want to give the color also. Suppose so, so color, suppose I want to give maybe blue. Okay, now I can close this one. GM smooth is completed. Now I also want to keep the title also, if you were interested. So maybe title from the previous, like I have given earlier also title like scatter plots. So this I want to give. Okay. So then if you want to save this one, you have to add a new line that is gg save. There we were just plotting the data, but if you want to save the your result, you have to write gg save. Okay, and you have to give your name. Suppose you want to give the scatter score, suppose score, age, and giving versus age versus score, and we want to save as png format. Okay, format you have to keep, and you if you want to keep the width also, and from this png is saving from this p1, so p1 you also have to mention, and then the width and height, how much width and height you want to take for 6 centimeters. 6 and width I want to keep 4. Okay, it's up to you how you can want to save. Okay, now you select those line, and if you run, maybe there is an issue. Okay, width and double same thing. I width and height. It's both the time I have written is okay. It's running. Let's see from here. Yeah, it has saved as GG save. Okay. For that we are just plotting. We are not only plotting, we are saving also. If you want to see that one, you just have to write the P1 and run. Okay. It will show here also. You can zoom, click the zoom button, and you can clearly see that. So we are doing the scatter one, but we are also making the smoothing one. Okay, this is smoothing of the all the data points, and this is the regression line. Okay, this way you can make the it's I have given the alpha value. Based on that it has smoothed, but it's up to you how you want to smooth. Okay, so this way you can give us a regression line in your scatter plot, and the same thing has been saved in uh, your file also. Okay, I will also show that. It will check for save. For that we to check the working directory. Or maybe we can keep the path of this so that it is saved. It should be saved in our particular file only. So you can give the path also. Yeah, you can see now this it has came to here. Okay, scatter score is it is saved now in our file also. For saving, we need to give the command as gg save. Okay, this way you can save your data. You can modify as per your need. Okay, this way you can write how, how you want to proceed. The tx file you have to make. I just give the comment of the latex file. You have to make the tx file, and you have to paste the comment from the result which you got from that uh, from this result. That this text rate function, what you have got the result in your console, you have to paste that one so that you get the table as it as you need. Okay, it will not directly keep the TX file. Okay, okay, so this way you can save the your file to your data to on data or graph to any particular file. Okay, I hope it is fine now. Now we can uh, do some more thing, but I don't want to go to much more things. I can add in the those art script. Okay, like we can do some bar plotting also similar way, and we can give some more. We can do some more residence wise. We can do or many more we can explore like this for your various graph, and we can save those. Okay, so these were some of the things we can do for after that doing the result save various testing thing. You can save also the plots. Okay, so now I think I should quickly go to the our NFHS one, and what was our motive uh, for the last day. That was we want to frame a research question, uh, want to make a research question, and we want to explore in our NFHS data. So I have given you a data which is as keyed sample. Okay, so if you are familiar with the NFHS data, if you are not, then it's fine, absolutely fine. I will just quickly show you what is the data look like. First, I want to show you the data type, the original data which is shared in the data format only. Then I will try to learn how to import the data and how to solve the research question. Okay, so first, uh, I'll just go to the data files. Yes, yeah, for the part one. This was the data kits underscore sample. Okay, so if you're familiar with this data format also, so this was the data, and it is for uh, Maharashtra only. I have given the Maharashtra. I have kept all the variables just for your if you what are the what how many variables are there. Okay, total there is 1644 variable in the Maharashtra kids file. Okay, so if you know, the NFHS provide various type of health related data, and there are four different type of files are there. Like kids file is there, which is made from the birth file. Then there is individual file in the sense it is the information of the women's of the reproductive age group mainly, and their main file is also there. There is household file is also there. Okay, so there total almost 6 to 7 lakh, I think, household has been covered, and almost 6.5 lakh women are covered, and among the kids, it is almost 2 lakh 20,000 or 25,000, uh, 30,000, I think. Total child has been covered in the NFHS 5. Okay, so among that, we have taken on with the Maharashtra one. So that means the file won't be very big, and it will easily can be run in our work for means we can easily do the solve our research question. Okay, so this is the format. So I'll now go to the R1. Suppose start new script I have started. Okay, I'll clean all the data what was there, and also clear the plot also. Is there any issue? Everyone has downloaded the data, or someone having some issue with the downloading the, yeah. I hope everyone has downloaded. Can't open the data. Yeah, means if you don't have the Stata software, then you won't be able to open the data, because NFS's data is being given as in Stata also, then SPSS also, SAS also, and maybe two or three format more. But directly it don't give. Yeah, if you don't have the data, that's what I was saying. If you don't have the Stata one, no issue. You can directly open in the R only. Okay. The how to open that in R, I'll show you. Okay. How you're opening in the Excel file, like you have to keep some library and import the data. The same way we are importing, we will import the uh, Stata file to R. Okay. So for that, we'll start like we have to keep some library details. So for importing the Stata format data, we have to keep we have to install the package called Heaven. Okay, so package name is Heaven. So for that, we have to install the package. So the package will be installed, then we have to call the library. Okay. So if you open that library, then you have to call that one. So suppose we want to give some name. Again, I repeat the same thing. This since I am giving the data frame name as DF only for my convenience. So for reading the this file, that Stata file, it is Stata file format is DTA. Okay, like the Excel has this for each format, like CSV file has .csv, or Excel file has .xlsx. Like this, the Stata file is .dta. Okay, for reading that data, we have to start writing read underscore DTA. Okay, read underscore DTA, and then you have to give the path of your data. Please copy your path wherever your data is. For me, it was just this is the path. Okay, this is my path. Fine. Now, if you run that one, it will start there with take maybe some time because the data is little bit bigger, so it will be it will take maybe 1 minute or so. Yeah, now you can see the data has been saved as DA. Okay, and you can see there is total 1644 variables is there, and total 9520 observation is there. Okay, you can see the data from the same way, clicking this table. Okay, this you can see the it is open the DA, and this is the data which I was showing in this data. Same thing you can see from here also. Okay, there are total 50 this type of seat is there, so you can go to the next one by clicking this double click. To this you can go to the next variable because there is too much variable is there. So want to uh, if you want to know which variables you needed, you need to have the variable list. Okay, so for that you can check all the your variable inform variable structure also. So what we have already see how to see the variable structure. For that we have to mention structure. It will automatically go all the variable details. Ready? You have to install the package first. Otherwise, it will show some error. You're facing issue like this. I just hit the comment in the chat box so that you can install the package. Just run the installation this package and library, then you can go. Okay. Okay, so this way you can see all the variable structure, how its level is there, how the format is there, it is numeric or character, all those things you can see for all the variables. Okay, so first you have to know the details of the variable so that means through this you can show all the variable labels also so that you can find out your relevant variables whatever you needed. So from that you can note it down the variable name. Suppose one variable is there like V025. It is showing the label as type of place of residence. It is the residence variable which is labeled as 1 and 2 and which is urban and rural. Okay, this way you can see for all the variables. You have to see all the variables details, and also if you don't want to see all the variables, you can give a try from this one. Maybe if it is case sensitive, so maybe sometime it also shows the error. Okay, so best way to see the variable details through the structure. Okay, so after seeing that one, you can also see like you can give the you can also check the names of the variable from the first 20 variables. Suppose we want to check. Okay, so for that the command is names. Okay, names is there, and then you have to mention the which data frame you want to see. Suppose I want to check the first 20 variables. Okay. If you run, these are the first 20 variable name in the data set. This way you can see means how the variables are there. Okay. Also the head function which we have already used like head of the DF means first few observation of the variables you can see. Okay. So but it won't see all the information because there are n number of variable is there. So it will show some of the variables, maybe it is showing only for the six observation, and total all the variables it can't show because the console size is limited. So it can be limited to some observation. Okay. So we have loaded the data. This we have seen from the this data from the data file only. Okay, the same thing can be if it is in SPSS format. The same thing can be done. Only you have to change your this format. The DTA format should be changed. That would be the SPSS format is saved as SAV format. Okay, so you have to write only the SAV. If you want to, if you have the SPSS file, you want to load that one, you have to check this one. Similar with various type of data, based on the data type, we want to, we have to change the path, sorry, we have to change the function name. Okay. So for today, I think we are just, we can have a small exercise, like if you want to check how the mother education suppose reduce the child stunting. Okay, so we want to check in Maharashtra how the mother education affecting the child stunting. Is it reducing or it is increasing? What the status? If you want to see the scenario from the data, so we can check that one. For that, we'll start like we have to make the variable. Our main dependent variable, yes, suppose is stunted. Okay, so we have to make the data stunting variable. We have to make, then if you want to check the main independent variable here, it is mother education suppose. Okay, how how much education the mother have. Then we can have some other variables also, other socio-demographic variables. Suppose we can take residence, we can take wealth condition, wealth status, or mother age. Any variables we can take, but we'll restrict to some of the variables. So that means the result won't be too much strong for us. We have to, it's based on your needs, you can modify those. Yes, sir. Means you can add your variables or reduce your variable. It's up to you. Okay. So suppose the variable which we are interested, like mother education. So mother education, the variable here we have to see which variable is mother education. We can check from the structure one. Okay. So here you can see the variable number is V106. Okay, V106, which is showing the highest education level of the mother. Okay, and it is a means categorical variable. It has a four category: no education, primary, secondary, and higher. Okay, it is taking value categorized in four category: 0 to 0 to 0, 1 to 3. So no education, primary, secondary, and higher. Okay, so this variable is there. Again, I have already shown key residence variable is there. It is V025. Then we can also see some other variables maybe. Okay, suppose uh, mother age, if you want to see, search the variable mother education, that is V012. Is respondent current age, because respondent means in the kids file the information is given by the mothers. Okay, because child can't give. So uh, uh, their age is only as the respondent's age. So that is also given, and that is a continuous format. Okay, so it is numeric only. So this way we have to identify two to three variable, three four variable we want to take only. So for that, suppose we want to check the variable 106, that is mother education. Suppose for that, suppose we want to give the data view which variable from where, from DA we want to take that P106. So if you run that one, you can see in a new window the PF1 has came, and it is giving that variable details. Okay. The same thing you can also see through a tabular format also. Okay. Tabular format, which is like a frequency one. Okay. For that, what we have to write? Have to write as table only. Like the tab we use, we have to keep the command is table. Okay. And we have to mention the same variable, whichever we want to see. Suppose we want to see this P106. So we can see the frequencies. It is categories in 4 categories: 0, 1, 2, 3, and these are the frequencies. Okay, 744, and then home education, then the primary, secondary. Okay, set the frequency of the total mothers education frequency, total number of mothers. Okay, and there is also a command as unique. Okay, unique is, if you want to check, okay, this way you can see this is highest education level, and these are the categories and what are the levels. So it will unique comment will give the details of it. My console does not show the variable like yours. Uh, is the same thing happened with anyone else? If someone can unmute and inform me.
I mean, I cannot, like, I'm running exactly the same commands, but these variables, I can't see it in the console. I mean, I have to search individually from the table, but like that is very difficult to do, right? Like, or I have
No,
to
no,
open data and then check the variables like this.
no, no. Did you run that
Ye-
strda?
Yes, yes.
There, from there you can see all the variable details.
It's not opening. It's just giving me the command there.
I
In
think
the
it's not showing them. I think the art system may have some issue. You can restart the art system and try one. Okay.
okay.
Okay. So this way the unique command you can run also, which will give the details of the variable, which is here from the mother's highest education level. Similar thing you want to see, suppose the 3025, which is the our residence variable. Okay, so if you run that one, it will give the type of place of residence, rural, urban wise. Okay, so 1 and 2, urban is 1 and 2 is rural. Okay, similar thing you can do for maybe wealth index if you want to check. So wealth index variable is P190. P190 suppose. Okay, it will work. Okay, it's fine. Uh, so if you want to check now the V190, then V190 is the wealth index variable. So wealth index is from 4S to richest. There is 5 categories showing. Okay, this way you can see all the variable details, whatever you needed from the structure STF, that structure one comment. Okay, otherwise you have to check from the variable view option. This is the way you can check your whatever variable you needed. So we have to check that those. Okay. Okay. So this way you can see the data and variable view. And now if you want to make some change in through the recording, you want to make some decoding. Okay, the variables which you are having the original variables, and you don't want to uh, means you don't want to take those variable as it is, means you want to make a new variable so that your original variable is not got hampered. Okay, so you can make a clone variable, means a new variable from the original variable, so that the original variable is should be as it is. And that can be, means maybe in the latter part also we need the original variable so that the original variable is not getting replaced. Okay, so for that you have to make a new variable, that is through the recording one. Okay, so for recording this one, we have already done the muted one for adding the column. We will do the same thing. Okay, suppose we want to make a new data frame. We don't want to hamper this data frame, the original data. We want to make a new data frame. Suppose we want to keep the new one as TF clean. Okay, so we are giving a new data frame, and what we have to do, we want to do the mutate one, means we want to uh, give the want to record or create a new variable. Okay, so for that we have to select from where we are getting the data. It is from the DF, this data frame. Okay, so for that we want to make, suppose the first variable, our main independent variable is stunting or stunted, suppose. Okay, so stunted variable, if you check, I'm not going to variable details. The variable is HW70. Okay, you can check from the variable view. Okay, so we want to make the new variable of stunting or stunted, if you want to say. Suppose we are giving a name as stunted. So I want to make this variable from where we are to take the variable HW70. Okay, so stunting is occur, the range is the value range is less than the 200 values only it takes. Okay, this is the definition of stunting. It will take only the values which are less than HW70. The value is less than 200. Okay, the Z score value only. So suppose we want to take the HW70 variable, and which are less, which should be less than 200. The issue is here. You have also have to address this, like we want to take, there may be some cases like we have not done any cleaning. So maybe there is some cases of NA is there, or flag cases, some could be there. Okay, so for that we have to take only the numeric. Okay. So suppose we want to make the numeric one, so we have to mention while recording this is as numeric. So we'll start writing as write as dot numeric. Okay, and in bracket you have to give this your formula, means how we want to take those values. Suppose we want to take these values is HW70 should be less than 200. Okay, so this way we can make those numeric one. Okay, so it will make it as a binary one, means less than 200 it will take as 1, or otherwise it is 0. Okay, 1 means stunted it will take, and otherwise it will take the 0. Okay, so this is one variable we have recorded. Then suppose we want to make the take the education variable, which is V106 only. Suppose we want to take the value as it is, education only. So it is a factor variable, as we know. So we'll take the variable as factor. It should be, variable should be as it is. So we just want to keep the variable name. So we don't want to hamper the variable, and we just making a clone variable of it. So we are taking the same format. The format was as a factor variable. Factor variable means the categorical variable. Okay. Same thing we can do for the residence also, because we also want residence to be one of our variable. So residence was also a factor variable. So same thing we can write like as factor and then the variable name that is B025. Okay. Then we want to gain same thing as the wealth one also we can do. Okay. So we can do the same thing for wealth also. Suppose we are making the variable as well. You for the to keep the comma here. So issue. So and one more thing we have to calculate, like we have to give the weight because it's a multi-stage sampling is done in NFHs. So while computing our estimate, we have to mention the weight. Okay. So we have to also compute the weight, which will be used for here taking the level survey design. Yeah. So we have made all the variables information and we have added five more variables: stunted, education, residence, width, and weight. So you can see in the DF tree, it is now five variable has been added. Okay. So you can check those variables also. Means if the variables are uh, fine or not. So you can do for through the table format, means what was the command table. Okay, table DA constanted one, but we have to keep the correct data frame. The DF clean in DF clean the stunted is there, not in the DF. Okay. So if you can see, the one is 7881 and 0 is 766. Okay. So this same thing we can do for other variables also, like we are doing for stunted. We can also see like for education also we can see the same thing, same type of observation which was there in the P106. We have just made the clone variable. Now, so the residence one. Okay, till. Okay, this way you can see the details. Okay, the variable details. Is it fine? Okay, so this way you can record one new variable. Okay. So
Sir, excuse me, I just wanted to ask a quick doubt. So, is
yeah,
there any difference between as factor if we put a as dot factor or as underscore factor? Is there any difference?
no, for numeric variable it is called as dot numeric, but when we give the as factor, it is given as underscore factor.
Okay, so thank you.
Okay, so this way you can give, and then uh, as this is a multi-stage sampling is done in NFHS, as we were mentioning, we have to give the weight. Okay, actually we should give us the we based on the survey design only we should give. So NFHS having the survey design with the various level. So for that we will create a variable as NFHS design. Okay, using the cluster variable, strata variable, and sampling weight. Okay. So for that, the we have to make a variable called, suppose we have to give a variable name as NFHS design, because we have to keep the estimate as per the weighted one. Okay. As in survey set, actually, want to give. So for that, we have to use the survey design command. For that, it won't directly can't run. For that, we have to run the library survey. Okay, so first you have to run that library survey one. So you can write library. If it is not installed, then please install that one. Install that packages. Under the installed packages, it just mention survey. Okay, it will be installed, and you can call that library. Okay, because this survey design function is built under the survey uh, library. Okay, so for creating the NFHS design weight, we have to mention survey design. Then among the survey design, we have to mention some of the variables like IDs. IDs is here. V0. Then we have to mention the strata number. Strata, that is V022. Okay. And then weight also. If you don't want to give the survey design, then the only weight file will also work. Okay. But it is always recommend to use the survey set design. Okay. To get a proper estimate. So I'm just creating that one. As the weight variable, we have already mentioned the sampling weight. Okay, and this all variables we are taking from the data TF clean. Okay. Okay. And then we have to write this. And as as this is the data is equal under the various clustering is there, so you have to also make the nest. Nest is like a nest means while when your cluster are within the strata is there, that is multi-stage in multi-stage design, you have to make the strata means strata which are there, which are nested correctly within the PSUs. Okay, so for that you have to make the nest equals to true. PSW70 is not found. It is found in my system. The same data I'm using. I will check properly. Maybe capital or small one you have used. Okay. So if you don't want to give the design, it is fine, but it is always recommended to use the designing factor. Okay, so this way you can do, and then suppose you want to create a suppose you want to check the variable frequencies. Okay, so first we have already checked the variable frequencies. So for suppose we want to check with the stunting with the education normal cross tabulation. If you want to check, okay, the command is table only. The normal table which we have used is table only. Just we have to add one more variable so that it will keep a cross tabulation. So for that, df will and dollar stunted comma the same. Suppose we want to do with the education, we just have to paste the same value like we do in other software also. So we have to means write the two variable which we want to want the cross tabulation. Then if you run, you can see the cross tabulation between the two variable 0 and 1, and among the 0 1, the education wise classification means education wise how the stunting 0 and 1 if there is stunted, how the observation is there. Okay, this is the normal frequency it is showing, and if you want to make it is in a percentage, okay, so for that you have to make the table into percentage mode. Okay, so for that what you have to do, you have to mention like this. Okay, proportion dot table, and the same command table in bracket. This command you can copy and paste this one. Okay, what the dot table do? It will make it into a proportion one. Means it will convert into proportion the same frequencies. Okay, and comma. If you want in row format, row percentage, it will keep 1. If you want in the column percentage, it will keep 2. Suppose I want the column percentage. So if you run this one, okay, it won't be run because no. Okay, if you run this one, it will give as the proportion one. Okay, so if you want to make it is in a percentage format, you have to multiply those into 100 with 100. So now you can get the your table as in percentage format. Okay, so this is the column percentage we are taking. You want to make the row percentage, you just have to change the last comma. 1 means the row, 2 means the column. Okay, this way you can make the normal means cross tabulation. Okay, so this way you can make, but if you want to make it a weighted one, then you have to mention the design. Okay, suppose I want to make a weighted table. So for that, I want to store that one in a separate name. Weighted table. For that, we want to use the normal table won't work. For that, we want to use the survey table because survey weight we are using. Okay, the command is survey table only. Then we have to make mention the two variable. That is our stunted one. Okay, stunted, and the second variable is our like we do in the regression plus the other one. So the same way we can write this stunted and education. Okay, then we have to mention the design. Which design? That is, we have created the NFHS design this video. So now the weighted table has been generated. And now if you want to see the weighted variable, you just have to just write the weighted table. You run that weighted table, you can get the same frequency wise. Okay. And similarly, if you want to in a row percentage wise, it's the same thing you can do like you have done for this way. You can send write proportion dot table dot table, okay. And if you mention the weighted table or you want to make in a row wise, then you have to keep the one. So it will keep as a proportion wise. But if you multiply with the 100 and get the row and column wise percentage. Okay, this is the estimate using the survey design. Okay, so uh, always while estimating, you should use the survey design so that your estimate should be correct. Okay, okay so I'll take just 2-3 minutes break, I think. Then we can continue to the rest of the estimates. Like we can do, and we can check the association also, like chi-square association. We can check. We can make some plot, and we can also check with the multiple multivariate regression also using maybe logistic, because the dependent main dependent variable is in our cases it is a binary variable. Okay, so I'll just stop for maybe 3 minutes or 4 minutes. You can start from there on. Okay, okay. Is it fine with everyone? Is everyone is getting? Okay, nice. See you. Yeah. Should we start? So I hope from now you have got uh, how we are importing the stata data, then stata format data, then FHS, then how we get the variable details, and how we can make into a table format, uh, cross tabulation or frequency table, how we can make, how we can record the variables. Okay, and now if you want to make normal cross tabulation, you can make through the table command, and then if you want to make in a percentage, then you can use that prop dot table command. Okay, and if you want to in a percentage format, you have to multiply with 100, and based on your new row percentage or column percentage, you have to mention one or two. One is row and two is column. Okay, and while we are doing a multi-stage means in a which is a multi-stage design, you have to mention the weight. Okay, survey design weight. So for that we are using the survey set design. Okay, for which we have created as an which is design. Okay, so that we have mentioned, and we have computed the weighted table of the two variable main variables, translate the main outcome variable and with the main independent variable of mother's image. Okay. So now if you want to uh, further go to more details, okay, suppose we want to make some plot, graphically we want to see, uh, maybe I'll come to the graph before we can do a main association. We can also check between the two variable. Okay, what we already learned yesterday regarding the association, that is chi-square test. Okay, so for that only the command we want to store also the data so that maybe it can be exported also. Okay, so I just want to store the data into this. I given name as tab. Uh, we want to first we have to, as you know, we have to make the contingency table. Last day also we have seen for chi-square test to check the association between the two variable, two categorical variable specifically. Okay, so first, we have to mention the two variable, which is this stunted and education. So I'll just mention those two. Okay, so it will make a tab. Now if you can see that variable of means what it is stored. This is the two means it is not 2 cross 2. It is like a four means 2 cross 4 or 4 cross 2, whatever you can say. Okay. So this contingency table has been made, and we want to make the chi-square test between, based on this contingency table. For that, our comment is chi-sq, chi-square dot text. Okay, and we want to make the chi-square text of that set tab. If you run those, you can get the chi-square value as 27 point something, and TF is 3. Okay, and then p value is 3.9. It is much lesser, so it is showing there is a strong association between the two variable stunted and education. Okay, and this is the normal chi-square test we have done. But if you want to keep the means if you want to give the service set design also, okay, you can also give that one. So for that the command would be little uh, that is the same way you can give, that is cvy chi-square. Okay, and you have to mention the two variable the way we are mentioning here. Suppose this new variable we want to make. Okay, we have survey design and sorry, under the service chi-square we are given the stunted and education. These two variable we want to check the association only with a weighted design, and we have to mention the design. So design equals to analysis design, what we have already made. Okay, it is calculating and it has given the result. It is also showing the result is coming significant because p value is much lesser and it has a strong association between the two variables. Okay, so as p value is much lesser than 0.05, it is rejecting the null association. That is, there is no association between the stunting and the mother mutation. Okay, but here this is unadjusted. What is unadjusted? We are not controlling the other factors, other socio-demographic factors. We are just directly showing the relation between the two variables. That may not be correct for existing when the other conditions are there. So for that we have to make the adjusted one. Okay, so for that we have to make the regression controlling the other variables. Okay, so that will come. Before that, we just want to also see how this stunting is showing according to the education. So for that, we can make a, bar plot maybe. Okay. So by education, how the by education wise, how the stunting and wasting is wasting and see how the stunted and not stunted are how the distributed is distributed. We can see. Okay, through the bar graph or bar plot, you can say. Okay, for that, what we have to write using the ggplot only. Okay, ggplot and what is the data from we are taking from df clean. Okay, then we have to make the aesthetic from where we'll take the x-axis and y-axis. X equal to, suppose we are taking the uh, education only, because education wise we want to show. Okay, and we want to make it like education only will show, but it should be categorized among the stunted and not stunted. So we want to make as a factor variable. We want to fill the bar as a factor one. Okay, so for filling that one, we'll make the variable stunted as a factor one, which will be like which will be showing as a factor of, which will be like a stunted non-stunted wise education category wise. When the bar would be finished, then you can understand what I'm trying to answer. Okay, so then we have to also mention the geom bar. Suppose geom bar, because we have to make the bar graph. So geom bar maybe position we have to mention, and position, suppose we want to keep, means how the bar should be there. We want to give the fill the all the, means you can give a dotted one, you can give other one, but I want to give the fill one, means color should be filled for each one. Okay, so this way you can give, and then you can give a label also. Okay, theme also you can give. I just don't want to give any other thing. If I run this one, this up to this only, you can see it is showing like this. Means this plot, if you see, it is factor stunting has a three category it is showing, because NA is also there. So if you want to remove the NS, okay, you have to clean that NS in your recording only. For that, what we have to mention means all the NS should not be there. that we have to clean there. So we for cleaning that one uh, in the first after creating the DF clean where we have created DF cleaner, after then only we can do like we can filter out those NAs from both the stunted and education wise. Means where the NA rows are there, they will be removed. Okay. For that we'll use the filter command. We are filtering out the NAs. So for that, we want to take the which data set we were trying to clean, DF clean only. Okay. So for that, we will not take if the values are NA, sorry, is.na. If the values are is.na from which variable? It is from suppose turn date. Okay. Also, we don't want if any NA in education also. So we are adding a more condition like is dot NA among the education. Okay. So if you run this one, okay, it will remove all the NAs from your observation. Now, if you run the uh, that code, okay, and if the ggplot is being run now with the DF clean. So DF clean won't be so now the NA is not there. So you can see the factor is only 0 1, no one yes. Okay. So this way you can means clean your data where the NAs are there. Okay. Is it fine? It's up to you if you want to take the NAs or not. Okay. Is everyone is getting? Okay. So this way you can also plot some bar also. So that means based on your needs and framing your research question, you can show also the how the distribution of the stunting children according to the uh, various education level of the mother. Okay. So this is one more thing. Now, we have also already seen now if you want to make, uh, want to check, we have talked about the chi-square which are showing the unadjusted association between the uh, two variables. Unadjusted in the sense it is not controlling the other factors. Okay. So now if you want to make, we want to take the, uh, uh, want to control the other variables, okay, we have to include those in our model. For that, we have to make the multivariate regression. So here, as the dependent variable is your binary one, okay. So it is logistic regression mainly it is used. Okay, so we'll use a you will do that logistic regression and we'll store that data. Okay, so suppose we want to make a regression and we want to store that under suppose model I'm giving, and as yesterday I was doing the GLM one, generalized least square model. Okay, so here we have to mention the our first we have to mention our the first uh, that main variable, main dependent variable, that is our for our cases it is standard. Okay. And we want to check with the others variable like We want to check with the education. Okay, we want to check and we are controlling the other factors like residence we can give. Then what are the other variables? Uh, wealth it is there. Okay, so wealth is it is there. Okay. And other variable also based on in rate you can give. I'm just sticking to these three mainly variables. You can give to the mother age also, that is V012 that we have not formatted. You can keep that one also, but as we have not done the reporting for mother's age, so I'm not putting into in this model. Okay, I'm just restricting into these two mainly residence and wealth index only I'm taking. Okay, and we are taking this data from which one? We are to taking the we are taking the very from that TF underscore T. Okay, and we have to also mention which generalized square model family it is from taking. We are taking from binomial distribution because the our main outcome variable is a binary one, binomial. Okay. Okay. So now you can sorry. Okay, spelling. Okay, you can see the that function has been run. Model function, which is generalized under the generalized model function, where we have taken the main dependent variable as stunted, and with the other three variable we have taken. The first one is the our main independent variable is the education, mother education. Then we have taken the residence one, and the third one is our wealth one. Okay, so these three variable we have taken, and we are taking the data from the TFP, means our data frame, and the family we are taking from binomial, that is our binary, means binomial distribution only, as the data very independent variable is a binary one. Okay, so we have run that one, and if you want to check, you can check as we have already seen yesterday with the summary function and summary model. If you run, okay, you can see you will take all the estimates, standard error, Z values, then P values from there. Okay, and various category wise it is giving, and the first category uh, is taking as the main with corresponding to that we are comparing with the others. Okay, so the first category is no education, we are comparing that with the other three categories. Okay, similarly you can see education primary is there, secondary is there, higher is there, and no education is our reference category. Okay, and then you can see with the residents, you can see with the rural, urban is taking as a reference category, and rural is giving the estimates. Okay, so if you overall, if you see, you can only see the higher one is higher education category mothers having influence with the uh, one second. So so higher education women's are reducing the mothers who have a higher education, their child are uh, less stunted, you can say. Okay, and that is significant in a little bit. It is a significant, but it is only the 95 in 95% 95% only. Okay, so if you this is only giving the estimates coefficient, it is going giving. as yesterday also we are checking. But if you want to take the um, uh, calculate the odds ratio also as well as the confidence interval also, you have to use the tidy model. Okay, tidy, uh, the function is tidy only. Okay, and tidy function will use the same this model only, and we'll write that tidy one so that it will also give the odds ratio also. Suppose we want to save that odds ratios result into in a function in a file name or df name, you can say, as a result. Okay, so where we can write the tidy one. Okay, we want to calculate the same from the model one only, which we have already computed from the logistic regression model, the same model. Then we'll use that exponentiate, that is means exponentiate of that estimates only to get the uh, odds ratio, because exponential of those estimates will only give the odds ratio. So we'll write expo, and that would be true because we want the exponential function of the those estimates, and we also want to calculate the confidence interval. Okay, so for that we can write CULF dot IN. Okay, that is also we wanted. So if you run that one, so it will calculate the odds ratio from the model, and as well as through the exponential of those estimates, this estimates of the this estimates is calculating the odds ratio as well as the confidence interval. So now the result has come. Now if you want to see those results, to run that one, you can see the estimates odds ratio, it is computed now. Standard error is also statistic is there, and p-value is also there, as well as the uh, lower limit and upper limit is also there. Okay, this way you can make also the odds ratio. So it is giving the odds ratio as well as the 95%. If the odds ratio is less than 1, it is like reduced odds substantially, and if it is more than 1, it's showing the increasing odds ratio. Okay, suppose it is in for secondary, it is like 0.924. Okay, so it is like children are uh, 0.1, 18%, you can say. No, sorry, 8% of the children are less likely to be stunted uh, against the uh, mother whose education is mother who has less no education mainly. Okay, because our reference category is as no education. Okay. This way you can calculate the odds ratio only, which will be used as to interpret your logistic regression mainly. Okay, so you can do like you can calculate like this, and then you can also export this result also into various
Excuse me,
format.
sir.
Yeah,
So how do we, what is the, how do we load the library for tidy? What is the code for that?
the ID model is not running in your system.
I don't know, sir. When
No.
I gave the error, it shows that I could not find the function tidy.
Okay, maybe last year we have shown the ID model. This was under, I think, this Bloom. Can install the package as install.packages, and the library name is Bloom. BRM. Okay. Last day we have already installed. That's why my system is automatically taking that one. Otherwise, you have to write that. Okay, I hope now it will work for the linear system. Okay, so this way you can write, you can calculate the odds ratio also from the model, this model one from the logistic regression, where you are only getting the estimates only. But if you want to get the odds ratio only for comparison, you should calculate through this tidy model, so that you will also get the confidence interval also. Okay, so this way you can do. And another one, can see, you can export these results also, the last day which we have already shown, like sync one. You can use the sync one, so that you can get the result in what is say ext format. Okay, so can I can save like this model.txt summary, which data we are taking. Okay, so this way you can save your model into text format. Okay, and similarly you can also save your model in Excel also. The same way I have shown you, like write.xlsx. The way we are exporting the Excel, you can same way export your result also. Okay, is it fine? Okay, so these are some of the things were there, and you can do means this was the main thing we want to explore only. Further, there are various type of plot you can do, like there is forest plot is there, but that is little bit tricky. Uh, so that can be done with it visualize the OR and CI also, how to do that. So that can be done, but I don't want to go to that because it would be really tricky to go there. For that, we have to make some changes. We have to make the data that way. Okay. So mainly what we want to explore here, how to load the data, the data format data or spaces format data maybe. Okay, then how we can clean the data and record those based on our need without hampering the original data. Okay, then we can explore the percent, I mean, prevalence of the stunted by uh, education mainly we have seen. We can also show, means we can also calculate the stunting percentage only with the simple the table command, this table command. And if you want to make the proportion of those, you just have to multiply this proportion with 100 to get the percentage. Okay, simple. You can calculate the percentage. Then you can by cross tabulation you can calculate it. Use the normal table command also. And if you want to get it in a using the survey design command, you can also do that. Okay, just you have to calculate the survey design, that function you have to calculate so that your estimates should be correct. Okay, then you can for only means if you want to do the main check the association between the main two variable, that is in our cases it was like standard and education, then you can directly do using the chi-square test. Okay, it will say the DP between the association between those two variables. Okay, and if you want to also apply the survey design, you just have to use the function survey chi-square test. Okay, then for calculating the adjusted one where there is other socio-demographic variable is there. You have to also mention the other variable. For that, we have to do the multivariate. In multivariate, what we are doing, we just have to we have to use the generalized square model, GLM, and then we have to take all the variables. I have taken only three, four variable, but it's up to you. It's up to your research question. You can take multiple variable also, and you can do this. We have to mention the data from where we are taking and the family. From for our cases, it is a binomial, so it is taking the logistic one. Okay, so you can calculate the model, and then if you want the odds ratio or other thing, for odds ratio, we are taking the exponential and confidence interval also, so that we can get our estimate in a proper format to compare between the two various groups. Like here, we are comparing with the no education with the others, and with poor with the other category. So this way you can compare. And we have also made a bar plot to see the how the education wise stunting is there through the bar plot. You can make the other graph also. Okay, this way you can do the your you can explore your fields. It's totally based on your need. You can explore. Okay, so I think that's it for from my side. Uh, if you have any queries regarding this, you can ask me. If you were facing any issue in any place, you can raise the query. Otherwise, I think uh, what was in our agenda we have almost tried to complete it, but I'll say means in 4 days we can't cover everything. Uh, I've tried to cover as many things as possible, and I want to give the basic environment uh, familiarity with all of you. So that means you can start working and explore the things. Maybe it's without practicing those things, it won't be easier. But to remember and to means familiarity with the environment is much more important than knowing how to do that, because the logic should be clear. Otherwise, it won't be means if you start in any places, you can get various references from the internet, but the means how to do that and what you are doing, that should be clear to you. And if you're familiar with the environment, I don't think you'll face that much issue. Okay. And if you face any issue, if you need my help, you can contact me. Uh, okay.
Sir, I had a quick doubt. So,
Yeah.
thank you for the class. It was very insightful. And, I had a few basic idea about R, and, I could learn it a lot more through this workshop. So, I wanted to ask you when we compare both R and Stata for a
Mhm.
social science students, which one is more relevant in the current scenario? And, what are the different areas where R is more useful and what are the areas where Stata is more useful?
Uh, I think means Stata is also useful, means it's also very much user friendly, but the main issue with the Stata, it's needed the license. Okay, means it's not a free software. Also, if you compare the visualization R with the Stata, R is far more ahead. Okay, and analysis wise also means there are many more function or many more analysis uh, means models you can't write in Stata also, but it is easily available in the means the community is much more bigger also, and as it is free, so it is widely used in the world. Okay, so it's up to you, but I would recommend means if you can do the art, definitely do that. But if you're comfortable with that data, but you should continue. But please also try to include it for visualization purpose also, as well as various statistical analysis only. Okay, I think it would
Sure.
be helpful.
Yes, sir. Got it. Thank you.
Yeah.
Hi, sir. Thank you for the
Yeah.
class. Sir, I want to ask one question that, for example, if there are categorical variables like agriculture income, non-agriculture income, and salary income, and I want to club into one variable that is income type. So how we will do it?
So you have to do the reporting means like suppose there is categories 1 2 3 is there. Okay, so you have to make the 1 2 into 1. And it's whatever depends on your variable types. Okay, you have to mention which type should be go to where means 1 2 3 should be 1 or 2 to 3 should be 1. That's where you can report like we have done here for suppose we are giving the condition here like uh, here yes starting we are making PHW 17 which then 200 should be as numeric. Okay, so it is making the binary only. But if you give the multiple condition like if you give the variable name equals to 1 to 3, it should be taking it should be 1 or 3 to 4 which is taking should be 2. This way you can modify. It totally depends on your variables. You can report those variables also. Okay.
Okay, sir. Thank you.
Yeah. Okay, I'll share this code also with you guys with the same folder, the day for one. Okay, so that it can be used for your further one. And if you want to ask any question, you can contact me further also. Okay. Yeah. Thank you.
Okay, so before we end the session, I would like to thank our expert, Mr. Saurabh De, for his valuable time and delivering such insightful sessions over the past 4 days. So thank you, sir. And thanks to all our participants for your active participation throughout the workshop. And we also encourage you all to stay connected with the research wise for our upcoming workshops and training programs. Uh, Certificates will be shared next week, and the recordings of day 3 and 4 will be shared by tomorrow. So, with that note, we conclude the session here. So, thank you once again, and good wishes to everyone. Good night.
Thank you, everyone.